Hello, everyone.
Hello,
How
hello.
is everyone doing? Feel free to throw in the chat. We love talking to everyone. So definitely let us know how you're doing if you want to. If you, at least for those in the U.S., had it. Hopefully you all had a nice Thanksgiving, um, or Canada. But Canada's Thanksgiving is a different time, right? I think so.
Yeah, October, I think.
Okay. Yeah. Yeah, definitely. I was enjoying a very nice break, and I heard, well, David's in Florida, so he's definitely having a nice break.
Yeah, visiting some family down here. It has mostly been certainly warmer than where I was. Not apparently not very warm for Florida, but it's been actually very lovely. So yeah, it's been really nice.
I'm pretty jealous. I feel like we've started to see our first snow in Pennsylvania, which is like not not fantastic. But I mean,
Yeah,
it's fun, but I'm just not ready for winter just yet.
totally fair. Yeah,
Yeah. Well, I guess hello everyone. This is Linear Tigression, the data science show that David and I have been hosting. This is our third episode. So super glad that you all are here. Really excited for you to join us, and especially because today we have some awesome content from David. Um, I'll quickly introduce myself. I'm Miranda All. I'm a developer advocate here at Timescale. Um, and I'll mostly just be learning with you all today. And so take the reins, David. Go for it.
great. Um, oh, well, I guess so. I think I'm David. By the way, I don't know that I've said that. So I'm a senior software engineer here. Um, and I'll come up with other names at some point. But yeah, so I'm going to be talking a bit about window functions today. We'll go over a little bit of how they work and how to use them. This is still a work in progress. This is a bit of a sort of, I would say, how would you call it? It would be a workshop, I'd say, of some stuff that I'm working on for a blog post coming up. But I think that yeah, I think it's a really interesting topic. I think you'll like it. So let's. I think we'll just dive in. I'm probably going to reach a point where I'm certainly going to reach a point where the slides sort of end because I haven't made all of them yet. So you're getting a sneak preview of some stuff that will be coming down the line, and we might do a more full version. But what we'll do is we'll switch over to just a SQL editor and go over some stuff that I'm planning on talking about. I'm sure I'll forget some stuff, but this really is great for me, and I would love to hear your questions because that's also going to help me understand better what I should be covering as we make this into a more as we fill out the rest of the blog post and other sorts of stuff. So your input would be really greatly appreciated. So yeah, so I think window functions are magical. And I mean that in sort of all of the senses of magical, right? So I would say that window functions are incredibly powerful, but they're also rather mysterious or supernatural to many people. And there are a few reasons for that, I would say. Um, one of them is that they're just generally a bit arcane. Um, one of the reasons for that is that the documentation about them in Postgres, for instance, is just like sort of spread out. You start maybe at the tutorial and the window functions tutorial, and then we might go to the more advanced syntax, which has some like which is about SQL expression. So that's going to tell you how to use some of the other window clauses. And then you'll find out more about which other window functions are available. And then in order to really understand what you're doing with them, you need to actually look at the select documentation. And it's just there's a lot of stuff to cover. They're a little bit tricky. And I also think that we often don't provide enough just sort of best practices um, and an understanding of what these things are. So the goal of this sort of presentation is going to be to try and figure out what they are for people who may or may not know, and hopefully give a better understanding to those who already do know. Then we'll talk a little bit about syntax and some things around best practices. And then we'll go into a little bit more detail on how window functions work, and then talk about how we can use some of our hyperfunctions, which are some of the things that we've built in Timescale Toolkit, as window functions, and some of the ways that we enable that. So the thing that this we're only going to get through. They only have slides up through a part of 2 here, so we'll see how far we get. Um, but there's a bit of background information, and I'd love to hear your questions, and then we'll go in and start just writing some SQL, and talking some more. So what the heck are window functions anyway? And one of the big things is how are they different from aggregates? So when if you've seen, I think we actually went over this on one of our previous either linear digressions, but certainly I've had a couple of other both streamed video talks as well as a blog post on how aggregates work. You might remember this graphic. So when we talked about aggregates versus functions, we talked about how an aggregate takes a lot of rows and produces one result. So all of the rows in a group would go together and produce a single result, whereas a normal function has, say, a single row produces a single result. And we're only really using inputs from that one row to produce that result. So as an example here, we have this very simple table where we just have a couple of double precision numbers. Tables foo. We like to use that as programmers for some strange reason.
Classic foo table.
Yes. And so if we have a function like greatest, we're going to get the greatest between bar and baz for each row. So for each row in foo, give me the greatest value between bar and baz, whereas the aggregate is going to give me the largest value of, say, so, and that the aggregate, by the way, here is max. So the equivalent aggregate to greatest is max. So the aggregate is working on a basically per column basis. You could think about it like that. So the max of bar is going to be the largest value in the column bar over all the rows. And the largest value in baz is going to be, the max baz is going to be the largest value in baz over all the rows. So we're taking a number of rows and producing a single output, a single result. Now, with an aggregate, you would probably have a group by as well. Here we have no group by, so that's just considered a group by over everything. Consider it like that. Okay, so a window function works a little bit differently. So a window function is taking multiple rows, or it still produces, like a function, it produces a result for every row, right? So one row produces one result. But, so for each row, sorry, I should say for each row that we run the window function on, we get a result. But we don't have to take inputs from just that row. We can take inputs from multiple rows. So in this case, and those multiple rows, by the way, are called the window that the function is looking over. So I've highlighted one of the window functions because if I made them all, it would just be a tangle. But I've highlighted one. So result 3 is looking at rows 2, 3, and 4, and it's producing a single result that correlates to row 3 somehow. And so row 2 is looking at 1, 2, and 3 and producing a single result. And row 1 might only look at rows 1 and 2. Who knows? Like, it depends on the type of window function, depends on our window definition, depends on all sorts of stuff. So defining that window is one of the big things that we're going to have to talk about. It's also a part that I haven't quite gotten to making the slides on yet, but we'll get there. But defining the window is one of the things that we really need to do. And so let's look at what an example looks like before we go on, though. So we're going to take our same exact example, and you can see that here that I have something like, okay, select bar. I can now select the value, and then max bar over, and that over clause is important. That defines the window function. An empty window clause will just say over everything, much like we did with the max aggregate. And now you see that we produce that aggregate for each row. So if we have bar and max of bar, we can get that for each row.
So in this case, the window that we're looking over is going to be all of the rows rather than like 3 of the rows, which the last image showed.
Well, in this case, there are only 3 rows, so it is over 3 of the rows,
Right.
but that's only because there's only 3 rows.
Right.
Yeah, yeah.
Got it. Okay.
And so you can make this window function, this window definition, much more complex, so you can limit the number of rows that it's seeing. But the sort of most simple one is just say, well, over everything, right? And that's what an empty window clause will do. Much like if you do an aggregate without a group by, then you end up with the aggregate over the whole table, or the whole, everything that's defined in the where clause, I should say, right? So it's basically the same idea there, where if you have a window function without a window clause, you just have the over, which says, hey, this is a window function. Then, or not a window clause, it shouldn't say it's a window clause. It's actually the window definition. The window clause is slightly different. Should change that. So the window definition is empty, much like if the group by is empty, it just means everything. So, and just to give you a sort of hint of some of the interesting ways that you could use something like this, is then I can say, well, what if I wanted to normalize something? Well, I could use the maximum of a value to normalize it, and that's how I would define this maximum. So I define bar divided by the maximum as like some fraction of the maximum, which is a nice, maybe one way that we might want to normalize something. So that's one of the things that window functions can do. But I mean, we're just very much scratching the surface. This is the simplest of the simple as we're going here. So that's the really base example. So again, an aggregate takes a lot of rows, produces a single result. A function is producing 1 row per result, and the window function is taking results from multiple, or is taking multiple rows, but still producing a result for every row.
So you could almost think of, theoretically, you could think of window functions as kind of like aggregates and functions in one.
Yeah, I missed. I seem to have lost one of the slides that I wanted to have that had that definition. I wonder if it's no, it's just disappeared. Okay, well, I'll find it again at some point. Great, this is what happens when you're workshopping a presentation, eh? So yeah, so anyway, but yeah, so they're kind of like aggregates. Now, so one question is, are they just aggregates? And the answer there is, well, yeah, kinda. So most aggregates can be called as a window function. So the window function just says, I'm calling that aggregate over some subset of data rather than in the group by context. Okay, that's fine. So if I call an aggregate with an over clause, it becomes a window function, a window aggregate, really. Ordered set aggregates, I think, are not allowed there, if I remember correctly. So like something like percentile cont doesn't work. And then, but then there are also other sorts of window functions, things like lead, lag, and rank. So lead says, get me the next row looking in my window. Lag says, get me the previous row looking in my window. And rank says, tell me where I am within my window. So these are things that aren't aggregates in a sense, right? They only make sense really in a window function context, where I can have a result per row. Because like if I say lead as an aggregate, what is it even going to do? It's only defined for each row within that group.
Right.
So I have to, that's really only useful in a window function context, where then it's going to be defined for each row, but there's going to be something about it that says, okay, I'm looking at a different row. So a window function is really a way to look over different rows as well. And this is part of why, by the way, things get confusing with them, is there's a lot of stuff in here. There are some window functions. There are aggregates that can be called as window functions. It's not always clear which is which, but most aggregates can be called as window functions. There are other window functions as well that make sense only in a window context. And what we'll get into maybe sometime later is that there are, when we talk about sort of the internals of aggregation, there are interesting ways that Postgres can optimize them. The aggregates can be optimized to work within window functions. So that's another thing that we'll get into at some point. Probably not today, honestly. So let's talk a little bit more about syntax. So the first thing is, we're going to use this table looking at financial trades, tracking financial trades, and this was actually just given. Jonatas just basically sent me some place where he's got some of this data going. And so we have a fair number of trades here. It's a pretty simple table. That's really why I use it. And some of the analysis might be something that's easy for people to get. So we have time, a timestamp, a symbol, which is just a text saying, hey, this is what this is. And we have price and volume. So the price at which a trade happened and the volume that was traded. And I think in this case, this is like Bitcoin and Ethereum, but it doesn't matter. Could be any sort of stock or whatever else. And eventually we may have more stuff going on. So let's look at a syntax, the basic syntax over in window. So over basically defines, as we were talking about, that window function. So if we select star from our table, so that's one of the cool things. You can still select star, right, get everything, but then I want the max over everything as well for each row. Right, so the max over empty window definition will give me the maximum volume that was traded. Now, we don't see that maximum volume, but you know that exists. So that's what the over clause says. Call this in a window context, call this aggregate in a window context, and we can look at it that way. Okay, so that's sort of what this might look like. One thing that you can do is you can also use a window clause, which allows us to name a window. So this empty window we'll call everything. And then it might read a little better too, right? So I can say max volume over everything. And I define my window everything down here as that empty window clause.
And the window statement or keyword, I'm not sure what's the best way to describe that. But in the order of like SQL commands, where does it lie? Is it always kind of underneath everything, or?
Yeah, so window clauses are weird, and this is actually something that I'll get into maybe a little bit later in terms of best practices. So it actually comes after a group by and after aggregates. And I frankly hate that. I think that it's really confusing. And so if I have to use both aggregates that are going to then be grouped by, and then also a window function over the result of the aggregates, I will just put it in a CTE or a subquery. I'll put the aggregation in the CTE or the subquery, and if I need to do a window function and then do an aggregation over that, I'll put the window function in the CTE or subquery and then do the aggregation over that. I don't like that there's this asymmetry where you can do aggregation and then a window function over it, but no window function then an aggregation over that. So I prefer to just have that be separate steps and have that always happen in separate steps no matter what, just because I think that it's easier to wrap my head around anyway.
So at least like if you were not to separate out the CTE, like using CTE, like with an aggregate and a window function, the same statement. So would the aggregate happen on the data and then the window function applied to it?
Yeah.
And then you couldn't do the opposite order unless you use CTEs. Got it. Interesting.
Exactly.
Okay.
And so that is the way that it's defined. And so that's the thing that sort of bugs me, is that like you might forget that. It's also like just a little bit less clear what's going on. You end up with like weird nested aggregates and other sorts of stuff. So there may be times where that is better and where you really want to write it like that because it just makes things read better or whatever else. So like this is not a hard and fast rule, but I prefer, if I can, to write it with a CTE just so it's clear which way any of that is going.
That makes sense.
That's my basic like generalization. I also think that like as good practice, you should name your window clauses in a descriptive manner. So we named this window clause that is empty, right, as over everything. Because now when I read max volume over everything, it reads well. It tells me what's going on. if I say, and many of the examples in the docs and things like that, name the window W. Well, what the hell is W? That doesn't help me at all.
That's a good
Like
point.
naming your window something completely and utterly random and useless just really doesn't help me understand what's going on. So it's like naming a variable C or whatever it is. It's just not helpful in programming. So don't do it in SQL either. So like if it's bad practice somewhere else, like why would you do it here? So name your window, your window clauses descriptively. Just like you name your tables descriptively, right? If I just called this table for trades T, that wouldn't help anyone. Now, maybe it's useful when I'm aliasing it in the from clause. Okay, maybe I want to do that. But, and you don't want to go crazy with your window names and make them a paragraph and a half long. But I do think that you can find usually a reasonable window name. So, and we can go over that and think about that a little bit more. So let's talk a little bit about the next bit of syntax, which is partition by. So we can put this in a parentheses, and this partition by is kind of like a group by for your window definition. In this case, I put it in the parentheses. Like I said, I prefer to use the window, but for now we're just going to put it in the parentheses, and we'll switch between them and show you the difference and why, and we'll build up a little bit more of why I prefer to use the window clause rather than putting in parentheses like this in a minute. But so let's just think about what this is actually doing. So partition by is sort of like if I said, well, what if I got the symbol and the max volume and grouped by symbol. So I partition by symbol, and that means that I'm going to get each one. And then I could join it back, right? Like I could put this in a with clause and then like join back. That's essentially what's going on here. Is it says for each symbol, give me the max. And you'll see that the values here, the max for ETH and BTC, for ETH and BTC, right, are the same that we're seeing over here in that max column when I have the same symbol.
So you could almost think of it like the partition is splitting up your window into like however many windows, given the symbol that it's kind of tied to, and then it takes the max over the windowed period for that symbol. So it kind of like splits up.
So if the so what it's basically doing, I don't know that I like to think about it as splitting up my window, but because the window is sort of the split value in my head anyway. So the window is really the rows that I see. So it's saying which rows can I see as this row. So if I am BTC, Binance BTC, right, what it's saying is as that row I partition by symbol, it says I can only see things that are my symbol.
Got it. Okay.
So in my window, I only have things that are my symbol if I partition by symbol. If I were to partition by time bucket 1 hour, it would say, well, whatever bucket I'm in, I can only see things within that bucket. So partition by says I'm limiting the size of my window and only allowing things that are the same between my row.
Okay.
Does that make sense? Cool. So now let's, this is where I run out of slides. So let me, I'm going to now share a different thing. I'm going to share my Postigo, and then we'll start doing a few other things. Now we get on time. Good. Yeah, this is going to take far more than an hour if I were to do the whole thing. So at least with the speed that I'm going at right now, which is totally fine. So let me do.
So alternatively, you could, so how you wrote it there with the parentheses as the window, as opposed to stating, window and like defining the window later. If you were to use the, defining window keyword method as opposed to the parenthesis method, where would you also then put the partition still in with like
Yeah, we'll go
window
over that.
form?
I've got that
Okay,
here.
okay, okay.
So one of the things that I will note is that you can have multiple window functions, right? They can, and here I have it as max volume and min volume, but I could also have
Oh, here we go.
max price.
Sorry. I didn't see that you had switched screens, so I had to re-add you.
Okay.
That makes far more sense now.
Yeah. Okay. So there we are. So we have max volume, min volume, right? So I can have multiple window functions. I can also, and we'll go over this in a sec, I can have multiple window definitions. Maybe I want the max price over everything, right? In that case, that would be like that. But so if I just run this, right? So now, I have two things named max. I might want to name my values. I'm also seeing that this window definition, partitioned by symbol, right? It's getting kind of repetitive to have to spell that whole thing out rather than using a name. And then as you get and you build up more complex window definitions, and there you can get pretty complex window definitions. One of the reasons that I like using window clauses is that then it's more clear to me which ones are exactly the same. I don't have to compare the whole window definition. I just know if the names are the same, then they're over the same window definition, right? So this now is that same query. I would need to do, we need to add max price over each symbol. So this is, again, I'm trying to name this window descriptively. Each symbol, like if I say over each symbol, you kind of get what's going on here, right? I'm partitioning by symbol, and it's telling me over each symbol. Okay, that makes sense. I can read this aloud. If I have max price over each symbol, I get what's going on. As max price, right? And now I'm also naming, this is sort of another best practice, is name the outputs. Don't just treat them as max min, because now if you look down here, I don't know if you can see it, but it's just volume, max min, max. And like, well, what? I need something. Maybe it's not per symbol, maybe it's by symbol. I don't know. Whatever we want to call this, like you'll develop your own naming conventions, and then you can somewhat stick to them or modify them when you feel like. But so then running that, it's just a little bit more clear to me what's going on. Maybe not to everyone, but at least to me. Now, the other thing that you can start doing is I could actually have, say, multiple windows. I just separate it by a comma. So if I want to add another
be my next
window
question.
definition, I just add another one. So then we might say everything as my empty one, right? So those are the two that we know right now, and we'll add some more in a minute. But so, and now maybe I want that. So now I'd say, okay, well, I want the max volume over everything all overall, right? I don't know, like, so, and then I can run that and it starts, right? Like, yeah, this is getting to be a more complex query, certainly, but it's manageably complex. I can track everything back. If I look at something in isolation, I can see what's going on. If I look at a couple things together, I can see that, okay, each symbols are related in some way. Everything is a little bit different. I might have multiple of these, right? So that starts getting to be something that is, to me, this is sort of the type of best practices that I like to use. And again, this gets more complex as we start thinking about more window definitions. So let's just go back to our.
Because I'm assuming that there are a lot of other functions, in addition to partition that we could use within the window definition itself, right?
Well, there are really only two other things.
Okay.
So window functions have a lot of complexity and like a lot of stuff that can go on, but when you break it down, the window clause is really, there's only like three main parts to it. So when we think about what the window clause looks like, what we basically have are three parts. A partition by, and that's our sort of grouping.
It's what we saw before.
Yeah. we then can have an order by.
Okay.
So this says I need to order my window in such a way. Now, if we, so you notice that if we just use a partition by default, it's just everything. If we do an order by, then it's going to also tell us, hey, I want a cumulative sum or cumulative max, the max we've seen so far, given this ordering. So, and that's the default way that it does. So and then we can also have some sort of limitation, and really it's a range, rows, and it's a statement that determines what rows around the current row we can see.
Okay.
In our window.
Right.
And so you have to have an order by in order to use range or rows. Otherwise, there's no way to determine an order, so I wouldn't know what's around it. But if I have an order by, then I can use range or rows. Does that make sense?
Yeah. So just, maybe the viewers are picking things up, but I love asking silly questions. So
yeah, I appreciate it.
For my own sake. So order by is kind of allowing you to set up how you want your rows to be ordered, order by, so that you can then, specify, okay, I want the range based on, if you were to order by price, maybe you want the range or rows based on specific price ranges, and then that would say, what your window function is acting on. Is that kind of like an example of maybe how you would use it?
Yeah, well, let's see if we can make something like that. That's an interesting thing. Let's see what we can do. I'm going to delete that.
I think in examples myself. So
yeah,
that was at least the first.
So
one
you're saying, so select star, and then we want to, what do you want to get?
So I guess an example of how to use the order by with range. Can you order by in your window using price for this example, and then specify your window range to be based upon like maybe certain price ranges or like rows?
Sure. So let's say we want to get everything here, and we'll do it based on. Well, let's first grab my where clause because I don't want to go over everything, and we'll just grab a partition. Okay, so we have from trades where our time's the same thing. Now let's redefine this. So you want to say, well, let's still say let's keep our partition by symbol. So we'll say within a symbol, let's order by.
Oh, also, someone did ask for some of your queries, so don't delete any of your queries, because I was going to add a link to them later on. So just
cool. Well, we can. Yeah, I can. This thing has a history, so I can always go in.
Great. Okay.
Okay. So let's look at the order by in. Well, okay. Let's build up to what you were asking, where we're ordering by price, and let's just order by time, because that's a pretty common thing to do. So I want to know. So one thing that I might want to do is we'll partition by symbol. And a pretty common thing to ask is, well, what's the total volume as of a certain trade, right? So we'll still partition by symbol. So how many total Ethereum or Bitcoin or whatever we're looking at happened during this where clause? So between 9 and 12, how much total volume? So we'll do the sum of the volume. And we'll call it, and this is going to be a cumulative. Okay, so and then we're going to order by time, and we'll do it ascending. So that's the default. I don't have to specify that, but it's a little easier. So we'll do the sum, right? And maybe we also want the average, the running average, right? So, but let's look at the sum just as a, so. Okay, so this is a cumulative by symbol sum, and I'm just going to run that, and we won't put a comma.
And so we
Okay.
need the order by in order to use the sum function. Is that because?
Well, no, I could, so, sorry. So I could also, let's define another window. So let's define, well, actually, we'll just take our each symbol. Well, actually, let's take all of our windows. And everything. So let's look at the difference here. So what we're going to do is we're going to do sum over cumulative by symbol, sum volume over each symbol. And let's name these. So like cumulative volume.
Yeah, I'm curious because at least initially I would think my brain, would look at this, with not being super familiar with window functions and assume that the partition by symbol order by would the sum would give you the same result as just the partition by symbol. But yeah, I'm curious to see the difference.
So that's over all the symbols. This is over each symbol and then cumulative by symbol. So let's take a look at what this gets us. So now, and this introduces a thing. So right now it looks like they're all the same. So why? We'll go over why that is in a second. If I add another order by, I might be able to do something about that. So actually, in fact, yeah, we'll do. This is fine. So what you see here, and maybe can you see which columns these are? So our cumulative price, as I scroll and I stay within the same thing, it starts summing up. And so by the time I reach the end of my group, so you see how this is just increasing each time? By the time I reach the end of my group, then what I'm going to do is what I'm going to see is that I've reached my total volume by symbol price by symbol. Does that make sense?
So the order. Oh, sorry.
Yeah, go for it.
So the order by is kind of allowing the incrementation of the sum, or like the adding of the value. Is that?
Yeah. So the order by is basically saying, look, I want everything up until now. So this says this is the total volume that's been traded since 9 a.m. So in the first 53 seconds, we had 20.96, right? Because I've got 53 seconds over here, so we got 20.96 traded within the first 53 seconds. And then, if I keep scrolling down, by 10 a.m., I've got, we're now into Ethereum.
So like the ending time period, we would see that theoretically the cumulative and the total volume should be the same at the final.
So the BTC,
time period.
at the end, we will see if I keep scrolling enough and don't head over into. So we're approaching noon, which is when I told it we wanted to end, right? And you see here that we are approaching the number here,
right?
Right. Okay. And if we hit noon, then we'll get to that final thing. So this tells me this is, if I were just taking the cumulative sum of what I'd seen so far since 9 a.m., this is what I would know. And this is what I see overall. And then this is the total over all of my symbols. So in this case, there's only two, Bitcoin and Ethereum, but there could be many more. So again, naming these things well is important so that you know what the heck you're actually talking about. And then, yeah.
Oh, we do have some questions.
Yeah. Awesome. Well, let me just say one thing before we do that. So you'll notice that there are some ties here, so that there are some repeated numbers. So why are there repeated numbers? It's because basically I've only specified my order by up to this. So if I add more things to my order by, like there's ties. So all of these happen at the same second, and we're not going to more detail than a second in our data. So all of these effectively happen at the same time. So these are all ties. So it includes everything up to that tie. And so that's why it's constant for a little while and then it switches. Now, if I were to add more things to my order by, so if I said, well, okay, once there's a tie on time, then I want to order by, let's say, price.
Got it.
And then volume, you'd see that this becomes more much more granular, right? Because none of them have the exact same of those. So now you can sort of see as this really just sort of creeps. There's a lot fewer ties here, maybe none at all, and you can just see how that's increasing over everything as I keep going. And if I reach the end of my group, my partition, then you'll see that these are equal.
Got it. Yeah, that makes sense.
Cool. Okay, so let's do a few questions. We're gonna, if I went through remotely everything that I have on window functions, it would take more than an hour apparently. So, yeah.
This is great. I mean, I learned a lot just even in our first Windows session.
Yeah.
So this is awesome. So one question, the first one, is there a tutorial on installing the toolkit on Windows?
I don't know. I think you'd need to make sure you've installed Rust. I don't think we've done much testing on Windows yet.
I can make
I'd have to talk to other folks. I think that someone reached out to us on Slack. You may be the same person. So hi. Sorry, we haven't completely gotten back to you yet. It's I think that some folks are still out for the holidays. So yeah, that's something that we can try to get.
Gonna make a note of that. Okay. And then the next question is, how are window functions different from continuous aggregates?
Yeah, so window functions, how are they different from continuous aggregates? Well, so continuous aggregates materialize an aggregate, whereas a window function, so an aggregate, like we said, has a group by, right? And you're going to get one value for that group of rows. Whereas these window functions, you can do this sort of cumulative thing. Now you can use window functions over some continuous aggregates in order to get a like tumbling window. And that's something we haven't even gotten into here yet, is how you might define those windows. But you can do things like rolling, and we've actually set up some of the toolkit functions to enable some of those things, like doing roll up or rolling and doing them over continuous aggregates. But continuous aggregates are for defining an aggregation, not a window. And yeah, I mean, I can see where you might get a little bit confused, because a continuous aggregate needs to have a time bucket function. So a bucketed function is a bit different though than a window function. And the time bucket says everything within this hour, whereas the window function is really, it says, give me the raw data, or whatever is closest to the raw data that I have. So if I'm working on a continuous aggregate, then it's whatever's in the continuous aggregate. So at the aggregation level that I have, I want to look outside of that. Whereas an aggregate actually reduces the amount of data, so the number of rows. The window function is going to keep the same number of rows, but look outside of the row in order to do, say, a rolling average or something like that. So that's sort of the difference between continuous aggregates. and window functions. I'm not sure if that helped you,
And
tech mentor.
would you say to, this is just a question that I have kind of building on that. Continuous aggregates are really more based on like time, right? And with window functions, you could, like, you don't have to use time to order by, like you could just use price or
Yeah,
volume, which is
totally.
not something that we really allow with our continuous aggregates.
Yeah,
Is that
and
true?
though, yeah, I'd say that's true. I mean, I think there are ways around that with continuous aggregates as well, right? Like there are things that you can do to make that work, if you want to. We can talk a bit about that, but like it
Yeah,
is a
I'd be
little bit
interested in that.
more haphazard, I'd say, or not as easily supported. I mean, window functions like continuous aggregates are there to downsample data and to improve performance. Window functions enable a different set of calculations that aggregates just don't allow, right? Getting a cumulative sum with a normal aggregate or a continuous aggregate or something like that isn't really possible.
Hmm.
Um, you'd have to write a lot of queries with different where clauses in order to try to approximate something like that. And so window functions are really made um, to make that sort of thing possible, or a rolling sum or something like that. Those just don't, they're not things that are possible. There's no way to look outside your row without being a group, and then it just sort of falls apart. So you can do things like that maybe with lateral joins in an aggregate. Like there are possible ways around some of this stuff, um, but it certainly would be less efficient. Window functions are really the syntax to do that. They make it much more clear what's going on.
It seems like for the cumulative kind of column, yeah, window functions seem really simple as opposed to like anything that I could think of where it's like take all the time before this moment in
Yeah,
time and sum it. And then, like
yeah,
it seems like it is a very like, I don't know, fluid way of getting that cumulative sum or, whatever it is
yeah,
in that case.
exactly. And
Yeah.
when you think about how you might do that for even a rolling aggregate, so let's say, and this is where we start getting into also like defining our windows with nice names and things like that. So, um, by the way, sorry. So is
Oh,
that
yeah.
all the?
And then there's
Oh,
one more
someone
question. Yeah,
was
yeah.
the client. So I'm using Postico, which is a Mat client that I like, um, for these types of things. So yeah, so let's go over a couple more things quickly, and then I'm sure I'll still have a lot more stuff that we could do. Maybe we'll do this again next week or something like that if we want to push our schedule back a little bit, because
It seems like folks are liking the window functions, which I mean, I
great.
see them as super useful. So I'm glad
Yeah,
that people are engaging.
yeah. Um, so yeah, so let's take a look at. So let's do. So we already did a cumulative one. Now let's look at something like so, and this is something that we sort of did a little bit of, I think, a few times ago, where we talked a little bit about stat tag, but maybe it'll be a little bit more understandable now. So once we start thinking about how we do this order by, right now we can think about also adding a range clause. So let's keep the cumulative, and we'll do it. We'll just add another one. We'll do a rolling sum. So I want to know, say, the total volume that's been traded, um, let's say in the previous 30 minutes. Or yeah, so in this case, it's going to be, yeah, the total. So it's going to be we're going to call this prev 30 as symbol order by time ascending. So we have that order by, and now we can say range, and this defines how far back we want to go. Whatever's in your range clause has to be in your order by, or it doesn't work. So you have to have the order by, and then whatever you're specifying has to be in there. So range, and we're going to say 30 minutes preceding. So I named this one prev 30, and so now we'll say, okay, I want the sum of volume over prev 30. as some last, or we'll say last 30 volume, or we'll say, actually, maybe we'll call this total volume last 30. Okay, so let's look at what this gives us. Oh, taking a while. Maybe someone else is using this database now. Or maybe for some reason that would be longer. I don't know why. Oh, does have to do more recalculation. Why is it doing this? Oh, that could be why. Well, that's annoying. So it does have to do some more recalculation here, which may be why. Maybe if I put a limit here. I don't need to do this for millions of things. Limit. Let's see if I put a limit here. If this helps. And let's order by something. Order by time. 1,000.
And so with adding like the range to kind of like the clause, is it still going to be cumulative as you're kind of going down in time? But okay, so
No,
now it's okay. So when you add range or rows, that kind of gets rid of the cumulative aspect, and now it's just looking at sections of the window. Is that right?
Exactly.
Okay. Interesting. Okay.
And there's no way to do a cumulative with a range.
Okay.
You can do things to the partition, or I don't think there is. I would have to look. I'm pretty sure you can't do that. So, because it doesn't really make sense because things keep falling in and out. So it's just like a little bit weird. Like the cumulative is basically there when there's nothing that's coming out of the back of the range, which is also why this is taking a long time. So anyway, I will.
Also, I put in the chat, is this the correct spelling for Postico so that I can?
Yes.
Okay. Just
let me try one thing. Let's try. And I'll do. I think that'll work. See if that changes anything. I might also have just, there we are. Hey, turns out StatSag is better for this. Look at that, fun. So, okay, so this is giving us the total volume in the last 30. And I think the reason that is because we accept some numerical error, whereas this was not. And we can go over exactly why that's happening sometime later. I think I know why. So this is giving us the last 30 minutes. And I should probably, now it's being ordered by time. So I'm getting a order by time. And we can do this order by, I wonder if it's even calculating it, if this actually changes it. Or if it actually runs it over everything. Let's see. Yeah, okay, so it seems like it's running it over pretty much everything, even if I do a limit. So that's something to just note on window functions. Like it's going to run it over a lot of stuff because it doesn't know what's in the window and what's out. So one of the things that you should know, and this is like a gotcha, is that if you want, so like first off, so if I'm ordering by time here, like my first stuff, you'll see that it's pretty small. And then once I get to 30 minutes in, it's going to be more consistent. And that's because, so let's look for like 9:30-ish, right? So once I hit 9:30, it's probably going to be like somewhat consistent for the rest of the time. but it's going to sort of be a cumulative thing up until then. And then it's going to stay much more consistent is my guess. And the reason for that is because if I wanted more stuff in there, like, so what you might want to do when you're doing something like this is actually go to 8:30. So you get the back and then select everything from 9 o'clock on out of what you have selected. Because in order to get the previous 30 in, it needs to be in the where clause.
Right.
So it's really not going to go look back further.
Okay. So really for this query, the only true sum for the 30-minute period you would get is from 9:30 onwards.
Yeah. So if I wanted to change that, what I would do is I would do from 8:30. And then I would basically put this into a CTE, I would say, with Windows as blah. And again, name your CTEs with something that's useful. In this case, Windows is pretty useful. Now I'm going to say select star from Windows, not the operating system, but our CTE. So maybe that wasn't a good name, where time greater than or equal to 9 o'clock, right? And so then I would get my 30-minute thing. I have my full thing in there. So I just do that. And, you know, that's going to give me the thing that I want.
Okay.
So now you'll see that total volume last 30 makes more sense, right? And it's more consistent. So that's a trick there, is like, if you're going back by 30 minutes, you might want to do something like this, where you first in your where clause go back by a window width, and then do a second select that gets you everything that's a full window.
Or like alternatively, the first chunk of time, you know, whether it's 30 minutes or 15 minutes that you have in your data set may not be accurate to like the actual sum over that, because it just doesn't have.
Yeah, it may not be accurate, exactly, because it just doesn't have the data.
Right.
Now, one of the things that you'll notice here is that this is pretty slow, and that's because I'm returning, does it tell me how many? I thought it would tell me how many rows. Query status. Doesn't say. So, somewhere it probably tells me how many rows this is. Yeah, so this is 250,000 rows, right? So I have to compute all this stuff for 250,000 rows. If you're not careful, it's like, as you can see, like this can start taking a while, even over 250,000 rows. I'm doing a fair amount of calculations. I'm sure if you were to do something like this in Python or wherever else, it would also be kind of slow, just because there's a lot of work to do. And so one of the things that we can probably hopefully get into next time, and I think we talked about a few weeks ago, was things like stats aggregate that allow you to more easily do things like tumbling windows, where instead of having this window function be over everything, we instead do it over an already aggregated data. So I say, you know what? I don't need this at the second level. I need it really at the minute level. That's going to make it so I don't have to do quite as much calculation. So I can either do that in continuous aggregate and then aggregate over that, or I can do it even if I do that in real time in just like another with clause. It's still going to be more efficient in many cases, because I don't have to, the window functions can be less efficient than a normal aggregate. And with some that works fine. With stats, with other aggregates like average or something like that, that's where you start needing stats ag and things like that. So there's a lot of stuff there that I mean, like I said, this is a big topic. Yes, you can use Windows with compressed hypertables. I don't think there's any reason why you couldn't. Yeah, I mean, once the compression happens, it's basically just scanning in. Yeah, sorry, I'm.
There are a few questions when you have a second. But
yeah. Okay. So let's do some questions, and then I think we're going to end for the day.
Okay.
So yeah, let's maybe go in order.
So I think the next question was talking about continuous aggregates and the time bucket function. Do you know when we could use time bucket ng inside of continuous aggregates?
Yeah, so that's yeah, let's put that off till the end, but I think that it may be available in continuous aggregates in a coming release. I'm not 100% sure on the exact schedule for database, but I think they are planning on adding that.
Yeah. And I think there was a small caveat to that time bucket ng, because it allows you to do different different bucket sizes because of month, the new ability for month. You can't use it for those uneven buckets right now, but it's they're working on it. I think there's
there are things that they're working on, and so it's going to be a little bit. It just changes some of the invalidation logic and other sorts of stuff. So there's some internal reasons why that becomes a little bit harder, but it's something that we are working
on. And then one question, which I know I see that Tech Mentor kind of figured out, but it's, I think, a good question to ask just for clarification for users and stuff. Is previous whether 30 the top? Yeah.
So if you specify range 30 minutes preceding, you could also say 30 minutes following. And then this would no longer be pre 30. It would be, I guess it would be following 30 or
post 30. I don't know.
I don't know. Yeah. So it would be the next. How about that? Next 30. That makes sense.
Oh yeah, that's good.
Next 30. Look at that. There we are. That's a good.
We got there eventually.
Yeah. So so that would be how you would go. Now the thing is, I think so, and this is where I even start getting confused. So and this is where things start getting really confusing, and I will definitely go into it more. But the range clause and the rows clauses here, they assume unbounded proceeding if nothing is put, but if you don't put an unbounded proceeding, then I think that it is assumed to not have a proceeding clause. So I think this will do next 30. Let me get next 30. Let me put this here, next 30, and then we'll do next. We'll call this next. So let's just look at that quickly and see if that works. But now, of course, this is going to be wrong. So we want to go from 9 o'clock, and we'll go to 12 o'clock or 12:30, and then this would be less than or equal to noon, right? So following row cannot end with current row. Oh God. Range from range between current row. Oh God. See, this is where I start between current row, current, and yes, I did it. I'm so surprised. Wow. See, this is where the window function syntax. So that's what you get for the next 30. That's how you have to define the next 30. This is how it's a little bit weird, but it's also one of the reasons why I like using my aliases. And so it says now start from the current row. So if you do following, and this is what I was trying to remember, if you do following, you have to give it a starting point. Otherwise it, so that's the thing that is going on. So it says between the current row and 30 minutes following, 30 minutes after, 30 minutes ahead might be a better way. But so that's where the preceding and following, it can be a little confusing. This is where some of the language isn't the best in window functions and things get a little bit confusing. And, so that's part of why I like to try and you'll see that this is different. And in fact, let's just to make sure that we're doing this right, let's just say and max time over next 30 as okay. Let me see if how long that takes, or if this is going to horribly slow me down.
We're getting real crazy here.
Yeah, it's not that crazy, but it is a little annoying. So I mean, but the basic gist here is exactly what this looks like, right? It's not that hard. I think max is not the best function to use. Unfortunately, we'd have to anyway. Doesn't matter. But that'll eventually finish, I hope, and you'll be able to see it. But the basic gist is, yeah, that you
So
can do that now.
so you could say that it's like, if we're using proceeding, it's taking the current time as like the end point and all the 30 minutes before. And then if we do following, you have to specify that we're starting at the current time and taking 30 minutes after.
Yeah.
Is that kind of a good way of wrapping it up?
Essentially, yeah. And so let me look at the.
I think we still have a few more
Compose
questions.
a window definition using other definitions. I don't know on that one. I'd have to look. I don't think so. I think that you have to just have multiple definitions. I think what I would. I mean, I think that if you use named windows, it usually isn't so bad. Hey, look at that. So let's look at the function. It finished, and you'll see that the max time here, right, is 9:30, which is exactly what we were expecting. That's the 30 minutes looking ahead. But you'll also see, by the way, right, that it's just like there's a lot of stuff here. So it is often better to try and do some sort of tumbling window. So you use a time bucket to get some sort of amount that you're willing to tumble, and then compute these window functions over that. And that's the thing that we'll talk about another day. Anyway, so composing window definitions together, I think.
So the hope is to look for a way to reduce the repetition inside window definitions.
Yeah, I think if you wanna be more specific in terms of the way what you're looking for, I can try to better answer it maybe next time. But yeah, that I think what I would do is mostly just use my names, because then I'm only putting the window definition once for each window, not for each time that I call it. So yeah, but then you can also do things. I mean, if you want to sort of nest window functions, you can do that in CTEs. So you could do partition by X, and then within, like, then you could do, but I think then you'd still need to partition by the thing in the next call. So I'm not quite sure what you're looking for, but if you let me know, I could try to maybe answer it next time. Cool.
All right. Hopefully
So I
that
think,
answers.
yeah, we're already over an hour. As always, there's so much to talk about. Thank you all so much for asking questions. It's really great to have folks doing that. And yeah.
Yeah, and
We'll
if there's anything that you have, more questions for, definitely feel free to. We have our Slack channel, which you can totally join, and David and I and lots of people are on there. We're happy to answer questions when we have time. We do try and get, especially if you call us out or something, usually we're more responsive, but we love hearing questions and hearing how we can keep giving you all more and better content that you would be really useful for you. So if you would like more on window functions, which it seems that is the case, we would love to do kind of like expand on it, as David was saying, with kind of getting into rolling windows and how we can integrate it maybe with time bucket functions and things like that. So definitely, I would be excited to hear more about that. But yeah, thank you all so much for coming. Have a wonderful Monday, whether it is your evening or morning or whatever. Have a great rest of your day. And definitely come next week. We'll be streaming again. And looking forward to hopefully seeing you all there. So, yeah.
Yep.
All right. Bye, everyone.